All right, I guess we can start. So good afternoon. Welcome to this EDBVF activity. The European Big Data Value Forum is one of our flagship events and really meant to bring together innovators and researchers and people at the front line of innovation in healthcare. This specific event, and I'm trying to imagine that we are in a big room, right? So I'm trying to get to have that kind of interaction today. So what I visualize is that many of you are in research or in innovation or at the front line of healthcare implementation. And this session today is really talk about how do we realize the potential of AI and data in healthcare. There are many aspects to that and many lessons learned from people who've been trying, people who have been implementing things. And it's a great platform to learn from these people. And today we have a very, very strong panel and presenters, of which I'll be zooming into their backgrounds. What you can expect today is to warm up with two presentations. And I will introduce these presentations shortly. And after that, we will have a bigger panel of some of the people that you see on the screen today. And all of them will have a thorough introduction. Either they introduce themselves or I will give some background information of who they are. There is also an opportunity to ask questions, and I'm sure that the navigation of this Zoom call will help to facilitate that. And if you are on social media, you should use a hashtag of EDBF so that we can find you on LinkedIn or Twitter or wherever you want to disseminate the information here. So let's kick start. Today, I would like to start with Annika Eberstein. She will be talking about realizing the potential of data and AI. She is currently the Secretary General at Interim at Kocia. And she has a very interesting background in European studies and political science, but also a broad experience in digital transformation, especially in digital Europe, and most recently in Kocia. So Annika, please take the floor, and we will be listening to you.
Thank you very much, Giorgio, and good afternoon to everybody in front of the screens or in Slovenia. So indeed, so my name is Annika Eberstein and I represent today Kocia. So we are the Trade Association of Manufacturers of Medical Technologies and Digital Health Software in key sectors related to medical imaging, radiotherapy, health ICT, and electromedical. This is usually when in a presentation on artificial intelligence say that AI is the future of healthcare. It's not, it's the now of healthcare. So certainly from our membership, we already see products on the market, also in the European Union, or very, very close to the market. So we have done use cases from our member companies that you can find on our website. I have just on this slide here done a selection of different applications of machine learning and artificial intelligence, be it to plan radiotherapy treatment, or for example, improve image quality in magnetic tomography resonance devices. We have done quite a bit of work over the last 10 years to really understand not only how artificial intelligence can technically improve healthcare right now, but also what the legal and regulatory frameworks and conditions need to look like to actually make it happen in practice in healthcare systems. And there are a lot of different elements that need to come together to really make it a success. To ensure that patients and healthcare professionals can use artificial intelligence-enabled software to actually, diagnose better, to treat better, to find the right treatment for the right patient. I will not be able in 10 minutes to go into all of those aspects, so I just picked a few of them that I then be happy to go into in more detail in the later discussion. So the first element that is absolutely central is data, data, data. Without data, there is no artificial intelligence. And I think what we have seen over, and which is a great opportunity for artificial intelligence, that there is now a lot of data in healthcare systems. The problem is who has access to it, who can use it, and also how to make sure that it is secure and safe in use, and that it is protected. And I think there's still a long way to go there. So we certainly see challenges in the near future, be it related to the implementation of the GDPR, or also how to make sure that the data that is available is of a high quality and accessible to manufacturers when they develop artificial intelligence. The European Union clearly sees that problem. So one of the solutions that is currently being proposed is the European Health Data Space, which may have been mentioned in other sessions today. And certainly there's a lot of promise there, although I think we're still very much at the beginning of the discussion. So we just see the first skeleton of what such a space could be and what it could look like. Surely the practical implementation will take years to come. I think the second element I would like to address is the issue of bias and ethics. We are working in a healthcare environment. So for us, ethics is not new. It always has been one of the most important aspects to consider when developing new solutions in a healthcare environment. Any time that a clinical investigation is conducted for a medical device, an ethics committee needs to provide an advice. So I think for us, ethics has always been at the core of what we're doing, and it also must be at the core of any artificial intelligence that is being developed. There are different types of bias, and I think, again, there are definitely healthcare specific aspects that we need to consider. Related both to the kind of group biases, for example, related to the ethnicity of patients that are undergoing treatment, but also individual biases that could affect both the data that is being used to train and validate the artificial intelligence, but also how actually the output of artificial intelligence is being used in the workflows where the AI is being embedded. However, that is certainly solvable. We have tools to already address these kind of ethical dilemmas and trade-offs right now. So we have a regulatory framework that exists, the medical device regulations, and that, of course, for any software that is right now being placed on the market does require a clinical evaluation, risk assessment that always means that both the risks and the benefits of the software under investigation is being determined, and also that bias, as much as possible, is being avoided. If that is clinically relevant, there may very well be situations, there are situations where bias is even desired, where, for example, you do want that a certain software only applies to a certain population or only to a certain healthcare institution. And I think the second point is that ethics and bias is not only to be considered before software is being placed on the market, but throughout the entire life cycle of the software. Already now, you have to do post-market clinical follow-up. You have to check in with your users, with patients, to ensure that any device that is placed on the market actually remains safe and performant according to what was put in place before. So we have the medical device regulations right now. These have not been written with artificial intelligence in mind as they entered into force this year. However, they certainly have specific requirements for software-enabled medical devices as well as standalone software. And they certainly also include requirements that are incredibly relevant for artificial intelligence-enabled medical devices. So certainly this idea that you have to follow the device throughout this life cycle, that you have to make sure that it keeps performing, that you follow up with your users throughout the entire lifetime, is already embedded right now in our regulation. Different jurisdictions have decided to, like United States, like Japan, to modify their medical device regulatory frameworks to issue specific guidance, like US FDA has done for machine learning enabled medical devices. The European Union has very recently this year decided to propose a horizontal framework to legislate artificial intelligence that also includes medical devices and AI-enabled medical devices. If we all have to remember, and I think that's especially important for those that may not currently be working in the medical device field, medical devices are not pharmaceuticals. So it's not the European Medicines Agency that approves artificial intelligence in healthcare in Europe. We have the medical device regulations to harmonize requirements for safety and performance, for effectiveness. But then there comes the next step where actually manufacturers also have to provide evidence for not only the clinical benefits, but also for the economic impact of the device, a cost-benefit analysis. And that actually is currently a very fragmented approach. Every member state has their own systems, their own approaches, their own requirements. As Kocia, we have done an overview of that last year in November that I invite everybody to look at, and where there's still a lot of work to be done to actually determine how to practically ensure that there is return on investment, and also that healthcare systems get out of artificial intelligence what they want. I just finish here by saying that there are no serious manufacturers of artificial intelligence enabled medical devices and software that are trying to replace healthcare professionals. That's not the goal. Artificial intelligence is a companion to physicians. It's a tool to be used by physicians and technicians, the same as any other medical device. And that means that there needs to be coordination and collaboration in the system. There are responsibilities then on users to make sure that data is being managed, that risks are being followed up on, that the device is used in the right way, and that needs to take place in constant communication with the initial provider of the software. And we need to have processes and rules and also templates for how to do this communication. Thank you very much.
Excellent. Thank you very much, Annika. This was a very good introduction into the challenges when it comes to operationalizing AI. I really appreciate your zooming into the preconditions, the bias, the ethics, the risk mitigation that comes with it, and even the trustworthiness of your AI once it reached the market. So to me, this kind of shows that this is not just a single team project. It really constitutes working in an ecosystem. And our next speaker, Gregor Kocia, really embodied that kind of person. He's really an ecosystem guy, the co-creator and co-organizer of healthday.si, which is one of the biggest, if not the biggest, Slovenian ecosystem for innovation in healthcare. He's also known to be the international ecosystem coordinator of ECH Alliance. This is the largest independent European network of stakeholders in digital health. So clearly someone who is capable and to talk about ecosystems. So Gregor, the floor is yours.
Giorgio, thank you very much. Also, all my co-panelists, it's a big pleasure, and of course, dear audience. I hope I will not give misinformation. I do have to put out the claim that I don't work directly in AI. I do have access to a lot of people who do work in AI. So it might be that my claims are off topic, that they are not properly informed at certain points of time, but still a valid point for discussion. I hope this leads us into a very productive and fruitful discussion for the panelists and for everybody else. The sentence there is, my name is Gregor in Slovenian. First, a bold claim, artificial intelligence is good or even very good at predicting the past, especially if there's a lot of data. I would like to substantiate the claim a little bit later on. I would also like to warn people who are in IT, know Gartner, so the premium and prime consultant to IT. Actually, I would say a much stronger footprint in IT consulting than, for example, McKinsey or Boston Consulting Group hold among the management consultancies. So Gartner is definitely setting the standards that are being listened to, and one of the things that they warn is this hype cycle. So AI is, like many things today, is very prone to over-promising and then disappointing. It's also a feature that actually happens because we want to tell about something that is new, and everybody wants to sort of jump on the next bandwagon, and truly even a lot of money is there, so it's not unjustified in terms of getting some funding. However, we do need to go through this through of delusionment to later on come to this, as they call it, plateau of productivity. So in spite of my, let's say, a little bit skeptical view, like it looks like it now, I'm still a strong believer in a very good usability of AI in healthcare just as well. So what are the challenges? The first one is that data actually isn't available. And the story about data just becoming available is the story that has been going on for people who have been following healthcare for at least 20 years, if not more. So, I mean, we are repeating the story of where is the data. And please do understand that healthcare data is so sensitive, so valuable also to particular doctors, hospitals, and even patients, that is simply not freely available. So perhaps there will be secondary use data act that will enable a part of the data to be published somewhere, be useful. There are efforts to create health data banks. Leaders in this regard, definitely you will find in, let's call them northern countries, not to single out somebody. And we are talking about these efforts to put together even data lakes, so disparate data that is sort of floating around in different formats. Federated data sources sometimes also appears. Also, the quality of the data is very often very questionable, unless you actually work in a niche. A niche can be really nicely specified. Also, disease is something that happens outside of the rules, and AI really works well when it's at least in principle rules-based. So the first claim that AI is looking backwards, there's nothing wrong with that, but please do understand that a disease in essence is an innovation within the ecosystem of living beings. A virus wants to be innovative to be successful. And a doctor who wants to stop a virus needs to be innovative. Perhaps artificial intelligence can be harnessed in that way, but I shall speak about, other factors also appearing. Also, we have to be aware that medicine is extremely vague. It's far from just being a science of you put in A and you always get out B. Far, far, far away from that. So that's making conceptually a great, great challenge for AI. You can work with a box like that. You can work with a machine like that. With a human, that's not possible. Okay. So we basically, the result is that we have zero reimbursed clinical use cases in Europe today. If somebody has reimbursed cases, please come forward. I will gladly learn about the mistake. I will also speak about mistakes. So if you don't work in healthcare, I suggest you leave this panel, and it's not a joke. The reason for this is that healthcare is more complicated than it looks at the first sight. It's actually almost like a black hole of, misunderstandings, mistakes, and learning. So if you're prepared to learn, then enter, but at your own peril. So I do warn you, if you're just outside and you think you know everything about other industrial areas, healthcare is different. It's very different, okay? Now, what are the challenges? I will be very brief here, not to bore you with this philosophical stuff, but intelligence is actually not properly defined. There is a wonderful book by Stephen Jay Gould called Mismeasurement of Man. It talks about the occurrence of IQ, why it occurred. It was meant to define what is a moron and who is not a moron, in order to conscript boys to army. And the basic level was set at 14 years age. So if you are above the normal of 14 years old age in terms of your mental capacity, you can be a soldier. Otherwise, you can't be. The problem there is that you're not measuring intelligence. You're measuring something completely different. I will stop here. Digital cannot have a resonance. So you can't create what you can create on a string, on a violin. You will not arrive at resonances, at self-reinforcing loops. You only get them in the analog world. That is a big, big problem. You're only simulating. So AI is a wonderful simulation machine, but the discrete nature of the inputs limits this very particular effect that, I don't know, even Nikola Tesla was not just describing, but working on it really strongly. Gödel's theorem talks about limits of mathematics and logic, and it simply says that rule-based systems cannot be complete. So you can never create a rule-based system that will have all the rules in the system already, that you will not find statements that will actually contradict or be unsolvable. Alan Turing, one of the fathers of computational theory, has a very similar theorem to Kurt Gödel. Karl Popper states that in order to create knowledge, you have to meet two types of knowledge. One is data, or objective knowledge, which is, imagine a library. And then it's not on you to know the whole library. The computer can know the library. That's not a problem. But the actual knowledge appears when your subjective picture of the knowledge, so you have to have an idea of what you're reading, and motivation. When these two intersect, you will create learning because you will find mistakes in your representation and you will adjust. So the mistake is a crucial part of learning. And finally, economic argument why there's a problem. A marginal cost of things that can be repeated, which is AI can be infinitely repeated, is that the cost falls to zero. Eventually, this means that the added value also falls to zero, and it means that in this game, to gain profit, you will actually not create an economic advantage, rather just a part-time advantage or a temporary advantage. And eventually it will go down to like, do you want to be in the race for disk storage, like some of the companies that remained in disk storage? The actual value of storing a gigabyte of data practically fell to zero. Practically, not really. There are, details that are very important, but just for the experts. So that's the current limitations of AI. Now, still it's moving. FDA has more than 50 algorithms approved. EMA still doesn't have. Please correct me. I might be wrong. I'm not an expert. What is approved? Rules-based applications. They address narrowly defined tasks, like there is a insulin pump that really has to measure predict what the levels of blood sugar will be, and there is capacity to adapt to a pattern that each patient has, because we behave differently. Somebody eats a lot of, it will be, of course, it's a sin for a diabetic person to eat chocolate. Sorry to say that. But somebody has the habit of eating chocolate in the evening, like I do. I'm not diabetic, but somehow the machine should learn that I'm eating let's say a slice of chocolate every evening, and it can anticipate that. But it's a very narrowly, very good, very well defined problem that you are solving with AI. Of course, Annika made a much better picture of this fail-safe and trustworthy AI. So I think it's quite clear what we are talking about here. And I would like to stress that it's a great tool. Like fire always, we present it as one of the greatest early inventions. AI is a great invention. It will actually make us much freer if we understand the role of the human that actually uses it. So I think we have great future for AI. So we have speech to text and of course translational services. We have logistics in hospitals, for example. I think one of our panelists will talk about projects that are logistics, very important part of organizing healthcare. Repetitive cognitive tasks. So when there is, a lot of things to go through, but they are known, the pattern is actually known. Fine, excellent. Let's use a machine. That's not a problem. And that data-driven approach actually means the same. Now, why there should be no fear for doctors if they are, in this industry with their soul in a way, not just, let's call it for the money, but of course everybody has to survive. It's nothing wrong with earning. Is that actually there is a huge importance of actually not just understanding the patient, but of feeling the patient, and vice versa. The patient has to feel the doctor. Doctors will tell you about this, nurses will tell you about this. I'm sure you have witnessed it, even in some personal discussions outside of the medicine. They can be therapeutic just as well. The role of the doctor, let's just focus on the doctor, is not so much pattern recognition. Machines are really good at recognizing existing patterns. The role of the doctor is to always learn on the outliers. A little bit to the mistakes are the most interesting part of medicine, because they tell you a new story, and eventually personalized medicine, which is the future of medicine. I hope you can agree with me. I can comment on several therapies that are actually applied already. Is the story about how each of us is unique, and if we are unique, you will only be able to repeat this story of patterns to a certain extent, and then there will be outliers. And it's the job of the patient, of the doctor, to put this into the picture and apply this as a human. But he can use and he should use AI. That's my introductory speech.
Excellent. Thank you very much, Gregor. That was very good insights into the beyond the hype of AI, right? And I appreciate the zooming into different aspects of the conceptual idea of what is AI, what is intelligence, which is interesting because this is a good segue to the panel. And I would like to involve more people to basically build on what you, Gregor, and Annika kind of introduced us into. But before we do that, it would be great to have a proper introduction of the other people that are on the panel, right? And I just discovered that I didn't even properly introduce myself. So as a panelist, I'm Giorgio Moses, working at Philips. I'm in innovation and strategy, and I'm leading a team in next generation AI, where we're looking really at things like trustworthiness, responsible use of data and AI, etc. And also, I would like to introduce other people on the panel. The first one is Dr. Supriyo. And I would like to make this as interactive as possible. Just like we are in a panel, we imagine that we are in this room, and a few very sharp minds to have some very good discussions, right? So in the introduction, Supriyo, would you be able to introduce yourself to the rest of the people?
Yeah, sure, Giorgio. Thanks very much. Yeah, I'm Supriyo Chatterjee. I'm from the Data Science and AI department at Philips Research. Been here for the past 10 years. Actually, recently, I just concluded an EU project which focused on, it was called Big Metalytics. It focused on using big data in healthcare. Just to give you an idea, we had 35 partners. The project ran over 3.5 years. We have 12 pilots covering very diverse topics from population health, oncology, to optimization of workflows in hospitals. So yeah, I'm sure we will be discussing some of the learnings that came out of this project. And I think many of the topics that were touched upon by Annika and Gregor, we of course encountered many of those issues, and I can definitely relate to many of the points they mentioned. Yeah, so I think I'll keep it at that. I'm looking forward to the discussion.
Okay, very good. And I'll also like to introduce the last person on the panel, which is Anja Baric. I hope I pronounced it well. And Anja, you represent the Ruder Bošković Institute. Could you tell us a little bit more about that? And also, very interesting, your AI for Health initiative.
Yeah, hello everyone. I do wear two hats. I'm one of the coordinators of Croatian European Digital Innovation Hub called AI for Health.cro. So we aim to enhance Croatian healthcare digitalization through introduction of AI solutions. And we're very happy to be learning about that from our predecessor in Slovenia, which would be Gregor's healthaid.si. So that's one of the aspects. So I present a consortium of 16 Croatian partners that are here to basically serve innovators who are willing to go through that process from an idea to a minimal product to get something billable in the healthcare system. And we're very excited if we get as many cases, successes like that. On the other hand, I am a member of a laboratory for machine learning and knowledge representation at Institute Ruđer Bošković, the largest Croatian institute. And I have over 10 years experience in applications of machine learning in biomedical research, in proteomics and genomics.
Very good. So this panel represents a good mix of industry, academia, and the ecosystem who needs to enable these. And I would like to start with Annika to kick this off, because as I was listening to your presentation, I do see the potential, but I do also see the challenges, especially around data and having these things coming on the market. It feels like, in terms of opportunity and barriers, right? It feels like we are putting such a high restrictions or requirements on AI that it's almost impossible to deliver something that will not make mistakes, follow all the rules. Wouldn't that be one of the barriers, that we're putting too much of high requirements to AI, like it doesn't get a opportunity to fail?
Well, so I would like to make one remark on Gregor's presentation. I would be extremely surprised if the EMA had approved any artificial intelligence in healthcare, because that's not their job. that's actually not what they're supposed to do. In European Union, any artificial intelligence that aids in diagnosis, treatment, or management of diseases is undergoing CE marking. So that means it's a notified body who actually does a conformity assessment. So just one thing I wanted to say. And I think the next one is that we are talking here about healthcare. We're talking about software that can have a direct impact on life and death of people. So it is important that we have high requirements. And that's also why we in the EU have one of the strictest regulatory frameworks for medical devices. On the other hand, yes, we are in a global competition. We do see that especially the United States are very advanced in the development and placing on the market and use of artificial intelligence in healthcare. So we have to be careful that it's very easy to just put out requirements that make a lot of sense when you think about them from a theoretical point of view. For example, there always must be human oversight of artificial intelligence-enabled software. In the first instance, you say, of course, you always need to have a person that checks the outputs and makes sure, that there are no mistakes happening. But actually, what you see then in clinical practice and in the clinical studies that you need to put the device on the market is that there are use cases where maybe human oversight could only be possible or necessary after decisions have been taken or at specific points of the product life cycle. And I think that where it's really important that regulators and policymakers talk both to manufacturers but also to the users in hospitals and healthcare institutions to make sure that these requirements are actually practical in real life.
That's interesting. And Anya, given your view, because you have a very interesting ecosystem view, right? Where you have people interacting with your clinical partners, you see startups with different technologies. What, in your view, would be the barriers and also the opportunities that you see for AI to be more implemented and being part of the normal care delivery system?
So once you get to do a little bit of survey of how AI research is going on, you can tell that there is a lot of AI research and AI development in the field of healthcare. So if anything, this is one of the most interesting applications of AI right now, and there's a lot of scientific work being done there. However, when that should translate into products that are based on AI, there's definitely not an upwards going trend. So what it seems to be lagging behind is the technology transfer, right? So it seems that people do have the right ideas. They come up with new solutions, but to get them fully developed, commercialized, and certified to be used in a clinical practice is actually the part where Europe still has a lot of work to do. And mostly, I think this is due to the very sensitive issue of how this solution will be used, and all sorts of legislative issues and data privacy issues that are actually behind that. And they're so complex and so new right now that it's really hard for a small startup to connect all the dots. Obviously, you have to appreciate that there are countries which are much better and they started doing it maybe a decade before some other countries. And, they have at least a few examples where companies have gone through that process, they can learn from each other, but there are definitely cases where a startup or an innovator would feel very alone in the whole process and they need some kind of support and a place where they can go and ask these questions. What do I do? Is my AI solution, is it a device? It's not a device. If it's not a device, who's responsible? Is it EMA? Is it MDR? How do I get the national what are the national laws about it, because they differ wildly on implementation of GDPR, let alone on anything else related AI from country to country in Europe.
Excellent. And Supriya, if I may switch to you, because we're hearing the perspective of, let's say, the smaller startup companies. Would you be able to give a perspective of a more larger established companies and the same idea of getting AI into the clinic? What are the challenges and opportunities that you see from your perspective?
Yeah, sure. I think it's a multi-dimensional problem, right? That we're dealing with, and I think Gregor really highlighted one of the very key issues about data accessibility. You know, how do you actually get access to data in the first place? And it's also important to realize that even if you do get access to data, can you actually make use of that data or not? Because is the data quality good enough? You know, many of the times we have this tendency to think that if you get data access, everything is going to be resolved, right? And of course, getting data access is one of the hurdles, but are you actually getting access to the right data? Is the data actually there is it structured in a way where you can actually use it and make a difference to a patient? And I think that's one of the things that we don't always take into account. I mean, everybody's so engrossed in how to get access to the data, they don't know, they tend to ignore the data quality aspect. So I think you need to not only find out how to get access to data, but have good quality data, and that's reliable data, because at the end of the day, your solutions that you're going to roll out are actually dependent on that quality of the data coming in. So if you actually have poor quality data going into your models, you have a case of rubbish in, rubbish out, right? And that's exactly what you don't want to do in a medical healthcare environment. You don't want a case of rubbish in, rubbish out. I think access to data is one of things, access to good quality data. But it's not only about developing models on these high quality data that you get. Once you develop a solution, there are lots of barriers in terms of also rolling this out and rolling this out at scale. There are issues where if you roll it out in a hospital, we don't really have a good way of doing this at scale at the moment, because you also have to see how clinicians are actually trained. They are trained in a particular way. They're not trained to just have a system tell them, hey, go do this, right? And they should not do that either, right? But it has to be something where you use, for example, to assist you. But you also see the uptake of these solutions isn't going at the rate at which you would like it to. And it also, we have seen it depends, and we saw this in the big Metalytics project, even in a single hospital, right? It really differs depending on the experience or the age of the clinician who's actually using the solution. It's just that the newer generation clinicians are much more used to digital innovations, right? They're always using their phones, and they're dependent on their phones much more than people who are of a different generation, an older generation. So, and you see that the ones who are older, they see a particular result coming out and they immediately start questioning, right? And that's of course needed, but it's about trying to have education programs. I think that's also important in the medical education to make sure that the clinicians who are going out in the coming decades, they will work more and more with technology, right? So of course, on the one hand, you have the main education from a medical point of view, but you also need to know how to handle technology and what implication does that have? What are the boundaries and how do you deal with that? I think that also needs to go into the education system, because otherwise you're not going to get this uptake. You're going to just have a technology push, but it's going to get stuck at the rollout phase. So I think those are just some of the aspects.
Yeah, absolutely. And I would like to drill deeper into that aspects of uptake, right? But related to that and also related to data is, I like to tell this story. I used to work in Asia, and we were building a food recognition app for financial industry. Long story, but the food recognition app was trained on a database of Asian food. And right before launch, as we were stress testing it, I display a European dish. And of course, the app didn't recognize the dish because it's all based on Asian food. So this is very central to data. And Annika pointed out different levels of bias that can be in your data, right? Transpose that same idea into healthcare. You might not have all the data you need to create the AI that is scalable across, let's say, all European countries, because even though Europe is pretty much the same, there are local differences, right? So that would beg for more data liquidity. Like the data is liquid inside an ecosystem, there is sharing. And I would like to go to Gregor with this question, like how far are we to make data liquid? And let's say to take it to the food recognition example, that we can have a global food recognition app that just doesn't work in one part of the world because that's where you have the data, but it works across whole Europe. And being an ecosystem guy, I would like to get your point of view of solving that I would say one of the most important prerequisite, right?
Yes. I do. First of all, thank you, Annika, for pointing out that they are notified bodies. My mistake, definitely. So the MDR is the framework, and I'm not an expert again. So my role really is what Giorgio just said, is to be, let's say, a qualified networker. My background is physics, so I do have my position based on, let's say, the type of thinking that the study of physics brought to me, which is trying to understand the principles and then, inferring from those, which often doesn't work well. Okay, and the reason why it doesn't work well is that not everybody thinks in the same way, and I think it's super important if I want to be successful in an ecosystem network. I do have to acknowledge that even if somebody is not at the level of understanding of AI, you will always have people who are better experts than you. That's one of the learnings, okay? But you will also have people that have less understanding, but it doesn't mean you can't learn from them about something completely different. So before going to liquidity of data, and there's a little bit of, wisdom in what I will tell you right now, is what my mother said to me about a month ago. She, after many years, realized that I work in digitalization of healthcare. It's always hard for me to explain, especially because, it's a sort of an intellectual job. It's not shoemaking, or it's not driving a van or something like that. So understanding of what I do is, now she understands, yes, Gregor works in digitalization of healthcare. She said, Gregor, isn't there enough of digitalization already? Like, I fear more. That was, the hidden part of the sentence was, why more? Because, I'm afraid. She's like 73. Yes, 73. And the fear there is that she will be pushed versus more screens. Like, there's a screen here, there's a mobile there, there's, a lot of, these things that are not human. Sorry, I mean, an interface can be beautiful, but it's never human. I mean, the most human part of what I'm looking at are the faces that are hopefully smiling at a certain point of time. Now, let's go to data. I would like the goal to be clear. The goal for me is to enable my mother to live in her pension a life that is as fulfilled as it can be according to the status of, let's also call her well-being, or not having diseases, or not being on chronic, sort of medication or all this stuff. Now, how does it relate to AI? It does. It relates to AI, and the point where it relates to is that it's not the data that will give me all the answers. That's one. And the second one is, do I really want to just give all my data, like get naked in the data sense, really getting naked in the data sense, to a central authority that will be breached faster than, I don't know, a big Amazon, Microsoft, Google, that I don't trust anyway? I mean, why should I trust Mark Zuckerberg with my health data? And why should I trust a National Health Authority? Why? But again, coming back, I would like to share data if I see the benefit. So I would like my mother, if she has a serious lung issue, she doesn't, but if she had a serious lung issue, for example, I would like all the knowledge of the world to be available to her doctor, mostly, not so much to her, but to her doctor at that instance, like instance of her therapeutic episode. Now, how does that go together with big data I mean, there are ideas of keeping the data with ourselves and actually distributing queries. So today, what do we do today? We stack the data in one place and then we put algorithms into that one place. What if the algorithm came to me, like the query comes to me and says, I just want this little part of the data. And it will not be very it will not make you naked because it's specific to my pulmonary state. I'd be happy to do that. Like I don't have a problem to be searched when I enter the airline, in the airport. I have no problem. But if somebody stopped me in the street in Ljubljana and said, I'll do a full body search, I would freak out. So again, I am for AI. But the question of data is a very, very personal question. And I'm not against technology. I'm for technology that enables humanity. That's my point.
Yeah, so I guess the question for data is indeed a sensitive one in healthcare, right? And my experience is you usually don't ask for the data, you sell the convenience. So in the case of your mom, if I may, I would say for, let's say, an example, medication management. Let's say she needs to have a refill. So I would love to have her medication regimen, knowing exactly her adherence, and then maybe predict when her pill will be done so I can reorder and send it to her before she can go there by herself. You can create that convenience. And that's a great story, but listening to the data model of my story is your address, is your medical information. And we're not just talking with the pharmacy now, we're talking with the delivery system. So as you can see, the data could go anywhere. And I think that's the challenge with healthcare data. So you can sell the convenience, but as soon as you want to make it practical, you hit into these issues. And maybe circling this back to Annika, right? Because you brought this point of, the essence of data being the key to AI, but at the same time, the curse that makes it so difficult.
Actually, Anya has been raising her hand, so I don't. Somebody seems to be very excited to say something.
Waiting,
so.
Go ahead.
I'm waiting, but don't worry about it. I wanted to. I really like Gregor's example, but I wanted to maybe circle back to what Annika said before. I think a very important issue here that we always have to keep in mind while developing these solutions is the trustworthiness of our AI, and it's the selling the convenience, right? But people do have this way of being skeptical to the new. And because of what Gregor mentioned, and this whole hype about everything being AI just because it makes it sound cool and big and interesting and modern, we have to be very careful about these maybe first contacts of medical experts, but secondly also patients with the technology that they see as the first experience of AI. Its interpretability, explainability, and trustworthiness are absolute key, because if they see something new and that new scares them or proves to be completely useless straight away, they will shy away from anything else. It'll be much harder to get them on board later on than if the first experience is a useful one. So there's an example. If you go to an app store, whichever OS, and you type in blood pressure, you will get over 200 applications that are somehow handling your blood pressure or your problems with blood pressure, 200 of them. Someone's done an investigation. Turns out only 5% of them have been developed, including medical doctors. A lot of them are probably doing exactly the same thing. Someone going there, most of them are free. They will not know which ones are good ones, bad ones, which ones will help them, which ones will not help them. And you know what? Blood pressure is a very common thing. And unless this is done properly, it will actually bring so much animosity that people will just give up on it before they even tried it. So we have to be very careful and conscious about that, not overselling what it is, not overselling what AI does. Sometimes data is just enough. It doesn't have to be intelligence. It can just be analysis of the data. And just, be very honest about what it is and what it isn't, and not hyping it up too much.
Mm-hmm.
Then maybe, to follow up there on the whole data structure, I think that's why what the European Union is currently trying to do with the European health data space is so important, and also so extremely ambitious. It's not supposed to be a central repository of all European health data. I think also from a security point of view, that would be an absolute nightmare. But instead, it's really supposed to be an access point where, yes, you can share, exchange data, where then maybe in the next step, researchers and developers may then ask for permission to different data sets that are included, that provide access via this common point. And the discussions that are currently ongoing on the governance and, who has access to what data, requiring what permission, are extremely complicated. We expect a legislative proposal at some point early next year. And I think to get there is a lot of work and a lot of convincing also that the Commission and national healthcare authorities have to do. Certainly from our point of view, we do want to see a system where secondary use of health data is possible, because otherwise the type of software development we would like to see in the European Union is impossible. So that really means that then developers rely on data sets from outside of the EU, which cannot be the purpose. On the other hand, we also fully see that you need to involve the actual owner of the data, which is in many cases the patient, and explain to them, ask them for permission, make them see also the usefulness of giving access to the data. I live in Belgium. We do have electronic health records. Actually, those are being administered by my GP, my general practitioner. I have access to the online portal where also I can see if my GP gives access, for example, to my dermatologist or my dentist. And if necessary, I can pick up the phone and say, excuse me, but I don't think that is what I would like to see. And I think that's really important.
Yes, absolutely. So as we mentioned before, we want to make this as interactive as possible, right? So I would like to also give the audience the opportunity to ask their questions. There are means for that, and I'm sure these questions will be wheeled into our conversation. Now, we touched upon this next topic in different ways, but I would like to call it out and really curve out this specific topic about AI, because I think it's important. There's a lot of hype about AI, and there's also a lot of activity going on, but it's happening inside the labs. When you look at real world, you don't see that output. And that has to do with many aspects of adoption. And adoption is a key to having AI being successful. Now, courtesy to a good friend of mine who really laid it out very nicely, he mentioned that when you look at AI use, you could put it on two axes. One is the trust. When you come from lab to the real world, the trust is very low because your stuff is new. So you have to gain that trust of the users in the clinical environment. Now, the first thing you will have is underuse. So your AI is great, but nobody uses it because they don't know about it. So you have to train them to get to the over the underuse parable. And then you'll have another part where it might be overused or abused or misused before you get to the real use of AI. And these are the things that I would love to discuss with you. First, let me start with Cyprio. In terms of your experience of adoption of AI, what would you say are the key elements, especially for our innovators in the audience, right? What are the key things that you need to think about when it comes to adoption?
Yeah, I think adoption, there are various parts to it, right? I think when you're first coming up with a solution, people tend to underestimate the complexity of rolling out a solution, because you think, let's say if you're coming from a purely data science background, right? You say, hey, yeah, I get access to my data, I do the modeling, and yeah, I have an AUC curve, and hey, yeah, my model's performing very well. But there's so much that needs to happen before it actually goes out, right? Because if you see all the people who need to actually be at the table to have this discussion, right? You have people from a regulatory perspective, from a legal perspective, from an ethics perspective. You need to have the domain knowledge, the clinicians, of course, the data scientists as well. And all these people, I can tell you in our big metalytics pilots, they were all speaking completely different languages, and they're not used to working with each other, right? So this is a very, very unusual environment where you actually need to bring all these people together and they need to understand one another. Like a clinician says, yeah, I want to get this thing going and I need to get my data as soon as possible because I want to impact my patients, right? But okay, but then you need to also take into account that you need consent. And as Anika was saying, we need to have ways to gather this consent easily. You know, we had clinicians who were actually sometimes, because we had a special case of stroke patients, right? And in stroke patients, you can't actually get consent upon arrival, right? Because they're not in a state to give you consent. So we had to do retrospective, we had to get a deferred consent. And the problem with that is sometimes you didn't have a scalable system to collect this consent. So the clinician actually sometimes had to drive down to the patient's home to get consent and come back and say, yeah, we got consent. And just think about it, right? We're talking about stroke patients. We wanted to cover a huge number of patients. The amount of work that's needed to get this going is it's humongous, right? So how do you actually scale this up? How do we have consent gathering techniques which can actually scale, where you can't expect a surgeon after going through surgery to drive down after that and get permission from all patients. So I think that's one of the things. Then there's also the communication aspect where, if you look at it from a scientist's point of view, or maybe a data scientist, what do? They're saying that, okay, I have these set of parameters. I'm going to now try out some tests. I'm going to see if this algorithm works. And hey, I see that this algorithm isn't performing the way I expected it to. Why? Because I need these additional data points as well. And then they would think, oh, okay, I can just go back to the data and get those data points. But can you actually? Have you got the consent for that? Right? And then they say, oh, I don't have the consent for that. What do we have to do? We have to now go back and rewrite our consent forms or adapt our consent forms so that we can get this additional data set. And there you have several months just going off because of all the paperwork that you need to do. And the clinician in the meantime is complaining, saying, hey, I want these results as quickly as possible because I want to have a positive impact on the patients. So what I'm trying to say is that you need to have these people understand each other, right? And you have to get them to talk right from the very first day so that you can take all this into account. I'm not saying consent is not important. It is very important, but you need to have all the stakeholders on the table understand how the importance of the consent, and to also understand what you need to do to mitigate the problems that you might have in the future right from day one, so that you have a more efficient way of actually rolling out solutions which end up finally impacting a patient's life. Because if you don't do that, you're delaying things.
Okay, so basically, if I'm an innovator or a researcher and I'm listening to this panel, right, and we're talking about adoption, like how do I get my AI solution adopted? And basically what you're saying is, well, you have to start when you're in the lab already with aligning the stakeholders, making sure the communication is aligned, we're speaking the same language, and also making sure the operational aspect of the AI is well thought about, like how you get consent, etc. And maybe to the other panelists, what else? What else should I be thinking about in terms of adoption?
So I think there is, especially in a healthcare setting, there should be a distinction that is quite often missed between the recently produced data and data you acquire for the specific purpose of the research you're doing or development you're doing, which is then gathered in a way, thinking of AI being applied to it, or utilizing historical data. So if you talk about electronic health records and things like that, these these data are out there, right? We have them, and in a way you can do certain amount of things on them, provided you get the right permissions, etc. Don't get me wrong about that. But the problem is that these data have been collected for the pure primary purpose of treating a patient. They haven't been collected in with the sense of doing any kind of research or secondary use on them. So they quite often lack metadata, and they're not standardized in any way. And I think Europe is in a very specific position because it's, for such a large continent, it has so many different little members, so many different little systems that have been doing this historically in a different way. And one of the things that these health data spaces that Annika mentioned are trying to achieve is actually put that all on the same level and get them to be comparable in a way, so they can actually be utilized and accessed in the same way, in a standardized way, so they're interoperable in a way. So I think this is where we are very specific.
Yeah, that's a crucial point. Remind me of an interesting use case that was published recently. I cannot find, I will not be able to reproduce the link immediately. But it was an interesting story about an AI model that was built on hospital data. And the AI model kind of shown that if you have asthma and pneumonia, you are less likely to die. So the mortality risk was lower. What they failed to realize is that in that hospital, people who have pneumonia and asthma get extra attention. And because of that, the risk of mortality goes down. So if you don't have that context, you take that model and you're going to implement it in a hospital where you're going to send people with asthma and pneumonia to a lower level of care. So you really have to understand your research environment, the context of the data, and how that applies to a real world environment. I think that's a very, very important point. Because if you miss that, you're going to lose the trust of the future users of your system, and that will be very difficult to rebuild. So excellent point. Yeah. What else should we be thinking about when it comes to adoption?
I would definitely add to that.